So we understand a little bit already about object-oriented programming. One of the main things about object-oriented programming is the possibility to group together different variables and different functions which logically belong with each other because they reflect some sort of real object that we know of in the real world. And all that we really have to do is try to put all the stuff, all the information that we know of the object in the real world, we have to just fit that all into either variables or functions. So if it's some sort of statistic like an ogre's health or strength, that makes sense to be a variable, and that will be the member variables of this object, of this class. If it's not a statistic, if it's not data, but it's some sort of action that the object does, so then that will be a function in C++ code. It's a whole entire subject for itself to really learn how to correctly solve programming issues by figuring out how to correctly transform real-world stuff into C++ code, to think about it in the right way and to make the classes and variables in the right way. But we'll learn little bits about this stuff as we go on in these videos. The important thing to know is that designing your program and creating your classes and different variables is a very fundamental and important part of making your program. It's not just sitting down by your computer, by your compiler, and starting to type up all the code. That maybe doesn't even take as long as the most important thing, which is to sit down, probably with a pen and paper, maybe a whole bunch of other guys of your programming group, and trying to design and grasp and put together the idea of your program and how we will capture this in C++ code by making classes and objects and stuff like that. Many times if you just sit down by the computer and start typing up all the code just like that, you're gonna end up that could lead to trying again and again and again and deleting and starting to code it again and make it like this and make it like that, because we don't have the idea clear in our heads exactly what is it we're dealing with, what is the problem of our program that we are trying to solve. So in object-oriented programming, and in our case in C++ programming, it is very, very important to put lots of emphasis on getting your idea straight and designing your program before actually just sitting down and trying to put it all together. But as I said, I won't be teaching a lot of that art in these videos. I'm assuming over here that we're already holding at a stage where we already understand the design of what we're trying to make, and so we'll just go ahead and learn how to actually code that stuff in C++. But you should go ahead and search websites and different stuff to learn more about the art of designing your program before actually coding it. And you will find it all over the place that this is just as important, if not more important, than actually coding your stuff together. And I'm sure they even have classes about this type of stuff in school, colleges, and stuff like that. But for now, let's just get back to the syntax of making a class. Just as an integer is a type of variable of which you can make as many instances as you'd like, and each of these instances have their own number, their own value, and you can perform a lot of actions on each of these variables. Like on x I could do something like plus plus or minus minus, etc. The same thing is with the classes that you will be creating. They have stuff inside of them, just like the int has its value, a ogre has its stuff. Like in this case, the ogre has 2 integers. So it's actually an ogre has 2 integers, each of which has a number and a whole bunch of functions which could handle it. And an ogre also has a attack function, and as a matter of fact you can give it as many functions as you'd like and as many variables as you'd like. So making your own classes is like making a different type of type. Just like the integer is a type of variable, your ogre is also a type of variable of which you make instances. The way you handle these instances is a little different than what we saw so far with the regular integers. With an integer, To get the value that's inside of it, you just have to type the variable's name and you get what's inside of it. So you can right away print out what's inside of x just by doing that, because the name of that variable right away prints what's inside of it. However, with your own classes, like the ogre right over here, the way it's handled is a little bit different. You need to use the dot operator to access the stuff that's inside of it. Because, of course, t doesn't have a number, t has a variable which has a number. So you have to go inside of t and then inside of that variable to be able to give it a number. The same thing is if you want to print out that number, you can't just print out t, because how are you going to print out t? T doesn't really print out. If you want to print out the number that's inside t, you have to type t dot and whatever it is you want to access. As well as when you're going to use t's functions, you're going to have to type t dot and whatever function you'd like to use. Now, what does the word public over here mean? Well, this is very fundamental to the rules of object-oriented programming. The idea is that when we make classes in C++, we don't want to really expose any of the member variables of this class. We don't want to make them so much available for anyone to access, just as we did over here, just by typing t.health. That is a violation of the rules of object-oriented programming. In object-oriented programming, we don't want everyone to know all the details of the inside of the classes that we are creating. In other words, whoever is going to use this class that you are creating, whether it's yourself or some other programmer who's going to copy your class, we don't want these programmers to actually worry about the details of how many integers exactly is in this class and how do they work and stuff like that. The elegance of object-oriented programming is that all of the member variables are all hidden away and you cannot possibly access them directly. Or as it's called in C++, we make them all private. When you make a class, anything that comes after the word private with a colon will be considered hidden away and private, and you cannot possibly access them with the dot operator as we saw just before. If you try to compile this right now, you will get compiler errors because we are trying to access a variable and a function over here which is private, and we cannot do that. That stuff is hidden away because of the rules of object-oriented programming. So how do we actually use a class in a useful way? Well, the idea is that when you make your class, you should create functions which will handle all the details of how this class works and what it does. And the functions will be the only real ticket into the actual functionality of this class, whatever class it may be. So this basically means that most of the time you should make all of your member variables private, which means you cannot access them, as we saw, by using the dot operator. And what you should do is make a few public functions which will handle the member variables of this class. So if your ogre class has these member variables like health and strength, they should be made private, so you can't directly access them and change their values right away. What you should do is make these functions right over here, for example, or whichever functions you may need for your specific class. These functions will be public and they will be accessible to anyone who uses the dot operator. And these functions will be the ones that are handling the actual details, the member variables of this class. Like this function over here, increase health, will actually increase the health variable by 1. And this one, decrease health, will take it down by 1. Now, because the variables are private and the functions are public, if I try to access the health variable with the dot operator, I will get a compiler error. But if I try using any functions of this class, because they are all public, then I can actually call these functions. So again, making something private, like a variable or a function, means that you won't be able to call that function or use that variable just by using the dot operator. Making a function or variable public means that anyone could access it. Any programmer who's making an instance of this class can access it with the dot operator.